Hello everyone, here we are going to do some derivatives of exponential functions. So let's go ahead right on the side of the paper, write down an aside here. Now, these are exponential functions and they're compositions of an exponential function y equals e to the u. So here we have y equals e to the u. And in this case, u equals 3x. And we're finding the derivative, and the derivative is with respect to x. So when we take the derivative of e to the u, we use the chain rule. And the derivative set is what? Well, first we take the derivative of e to the u with respect to u. The derivative of e to the u is e to the u. And then chain rule says we multiply by the derivative of u, which is u prime. So you might not want to write that down or even think about that usually. The derivative of e to the 3x is what? Well, the derivative of e to the u, the exponential, is just e to the u. So I write e to the u, but u is 3x. And then I multiply by the derivative of u. The derivative of 3x is 3. And this looks a little bit like I'm doing the, possibly like I'm doing the, I don't know, a power rule or something. It's not the power rule. This is how you do exponentials. For exponentials, you take the derivative of e to the u, and we get e to the u. Then we go upstairs. The derivative of 3x is 3. So y equals e to the u. The derivative of e to the u with respect to x is e to the u prime. You could also write this as dy dx equals e to the u du dx. Okay, let's go on to the next problem here. We have e to the u where u is negative 2x. So as before, the derivative is e to the u again. And then we multiply by the derivative of u, which is negative 2. So in general, we have this formula. I shouldn't even say in general. We just have a formula, which is the derivative of e to the x is e to the x. I didn't say that right out front because I'm assuming that's known, but I'll put that there, okay? The next one, y prime, we take this derivative. This is e to the u. That derivative is e to the u. But again, we multiply by the derivative of u. Well, the derivative of u is 2x. So this is the derivative of x, of d dx of x squared is 2x. Next, we can highlight these solutions. Maybe we should do that. All right, going on to the next one. Y prime is e to the u. E to the u, the derivative is e to the u. And then we multiply by the derivative of u. The derivative of cosine x is negative sine x. A little bit cramped there. Let's move it over. Just move it over. Gosh. Oh my gosh. Okay. Let's check this one out. This is e to the u. The derivative is e to the u, but the times the derivative of u, and the derivative of tangent x is secant squared x. Should we do that on the side? Maybe. We have formulas. That the derivative d dx of cosine x equals negative sine x. D dx of tan x is equal to secant squared x. So it all, a lot of things fit together here. We need to use a lot of different things to be able to do these problems. But what I'm trying to focus on is the derivative of e to the x equals e to the x. And if we're looking at the chain rule, the derivative of e to the u with respect to x is e to the u prime. Okay, well, that finishes yet another video. Thank you. Take care. Goodbye.